This is a lesson on gas laws, and specifically the combined gas law, combined gas law. Back in the 1600s, when science was starting to get underway, people would be studying gases and come up with relationships between all sorts of different things. There's an Avogadro's gas law relating number of particles and pressure. There's Charles' law, there's a Gibbs-Sachs law, Boyle's law, lots of different guys' laws. Those don't really matter because you got something called the combined gas law. The combined gas law relates pressure, volume, number of particles, and temperature. And PV over NT, PV over NT. Pressure times volume. This is pressure. This is volume. N is the number of moles. And T is temperature. Capital T's are temperature, lowercase t's are time. So this is the combined gas law. And for any sort of problem that you have, if there's something that is not used or is called constant, you just cross that part off. So this one you can use for any situation that you have, as long as something is changing. This is the equation you use for change. You'll see words like new, what is new volume? You'll see two temperatures or two pressures or something like that. So anytime you see a change, the first set of conditions is this. What is under these new conditions? What is something going on? So that's what you use this equation for. The other thing you need to know before we go on and do the problems is STP. STP stands for standard temperature and pressure. Standard temperature and pressure. So standard temperature is 273 Kelvin, which is 0 degrees Celsius, and pressure is 1 atmosphere or its equivalent. If the units we're talking about is kPa, then it would be 101.3 kPa, the conversions that we had in the last program or problem. So sample problems that we do here. Suppose you have a volume of 14 liters at 50 kPa. What is the volume if you increase the pressure and the pressure goes to 125 kPa? Question mark. So you start with PV over NT, and for anything they give you a numeric value that's changing, go ahead and leave it in. If it's not there, cross it off. You do see pressure. You do see volume. You do not see any mention of moles or grams, which you convert to, so the number of moles gets crossed off. There's no temperature. It gets crossed off. Sometimes they'll say at constant temperature. If it's constant temperature, it doesn't change. So you end up with PV equals PV. The first pressure is from the first phrase of the first sentence, which is 50, times the first volume, which is 14, and the second pressure, which is the second phrase, 125 times the volume. Using your Algebra 1 skills, divide by 125 and solve for V. Remember, round in 3 places and label your answer. In this case, the volume is going to be in liters. Another situation, suppose you have a volume of 10 cubic centimeters at 0 degrees Celsius. What would be the new volume? The word new is a clue here. What would be the new volume if the temperature goes to 27 degrees Celsius at constant pressure? Sometimes they'll say constant pressure, something like that. PV over NT. Pressure is constant, it's not changing, so we don't have to worry about it. Volume you need, because it's asking for what's the new volume, and they give you two temperatures. The number of moles is not discussed, but the T you do need to keep. So this is volume over temperature equals volume over temperature. Plug in from the first phrase, the volume, which is 10, and the first temperature. Now, temperature has to be in Kelvin, because divided by 0 you can't do. 10 divided by 0 you can't do. So it has to be in Kelvin, so you got to do the 273 plus 0, which is 273. The volume, which you're trying to find out, and the new temperature. So 273 plus the new temperature ends up to be 300 even, is 300 Kelvin. So you multiply by 300 both sides, and 300 Kelvin, you got the volume. So you take 300 times 10 divided by 273, whatever that is, and round it to 3 places and label it. In this case, the label is cubic centimeters. One last example. If you have a volume of 30 cubic decimeters, and let's call it negative 123 degrees Celsius, and a pressure of 10 psi. What would be the volume at STP, standard temperature pressure? Remember, that's up here. PV over NT, the pressure we're talking about, the volume we're talking about, the number of moles is not in the temperature. So the pressure is 10 psi, the volume is 30, divided by add 273, which means it is 150 Kelvin, always got to change to Kelvin, equals standard pressure. Well, it's 1 atmosphere, but we don't have 1 atmosphere, we have psi. So it's 14.7 psi times the volume, which we're trying to find, divided by standard temperature, 273. Now, in this type of problem, you can cross multiply. You can do 150 times 14.7, whatever that is, V, equals 10 times 30 times 273. But it might be quicker, especially if you have calculators, to multiply by the reciprocal. 14.7 over 273, 273 over 14.7. Those cancel. 273 over 14.7. Multiply on top, divide on the bottom. So in your calculator, without having to redo anything, set down any intermediate here, you're going to have to figure out what 150 times 14.7 is, divide that into this. A lot of numbers writing, you can just do this all at once. On your calculator, 273 times 10 times 30 divided by 14.7 divided by 150 because it's in the denominator. You do that math, and you'll get the volume. Volume's in cubic decimeters, and there's your answer. And that concludes this lesson on the combined gas law.